Electron configuration. Electron configuration, we identify the shell and subshell that electrons are occupying and how many electrons are in that subshell. We start by reading the periodic table, and then after that we look for modifications to what we would get off the periodic table. So for vanadium, we check out the periodic table, we see that element 23, well, we have two ways of doing electron configuration, long form and short form. I'll do both forms for us. So vanadium is 23, so we have to show a total of 23 electrons where they are. So the long form, we are going to start from the beginning of the periodic table, hydrogen, and work our way up. Hydrogen is going to be level 1, sublevel S, and S holds 2 electrons. That would be hydrogen and helium's electrons. So we have that as a superscript. And we continue on up from there. The third and fourth electrons are going to be level 2, sublevel S, with 2 electrons in there. That would be the top level electrons for lithium and beryllium. Then we go on through boron through neon, right side of the periodic table, still level 2, but sublevel P. And there are 6 blocks there, so 6 electrons. So we come around to period 3. Period 3 is level 3. First 2 columns are S with 2 electrons in it. The right 6 columns will be 3 with sublevel P with 6 electrons in there. We go to period 4 where vanadium is. The first 2 columns are still S, 4S with 2 electrons in it. Vanadium's in the transition metals, so transition metals is D. First time that we see D is going to be 3D, so we're dealing with 3D. It's in period 4. And vanadium's in the third column of the D block, so that is 3 electrons. So that is the long form. The short form is the noble gas configuration. We start with vanadium 23, go down to find noble gas. That noble gas is argon. So we put argon in square brackets. That covers 18 electrons right there. So now we just have to deal with the period 4 electrons. So that would be our 4s2 and then 3d3. And it's not critical which one is listed first. This is how they're right off the periodic table, but we can do 3d3 and then 4s2, so that is not critical. Now, expected electron configuration of chromium. I'll do the short form of this. So we have chromium is element 24, so we go down backwards to the first noble gas. That's going to be argon. So we go back to period 4 where chromium is. First 2 columns is 4s2. Then we're in the D block, which is 3D. And chromium is in the 4th column of 3D, so we got 3D4. Now this is the periodic table version. But that's the first level information. Second level information is that we're going to look at this and go, this is not complete. So what we're saying here is that we have the S and then the 5 orbitals of D. So we're saying that we have 2 electrons in S and 1, 2, 3, 4 in D. But we have this missing one over here. And we have paired up 1 in S. Well, we have 2 energy deficits in this arrangement. The systems, the atoms, really like to have either half-filled or completely filled sublevels with And if it's half filled, they're all going to be parallel spin. Parallel spins give us a benefit, energy benefit, and then one or two, but a complete pairing of electrons in our orbitals, such that we have all of them occupied, is a preferred energy set. So what this element does is it promotes an electron up into the D level. So now we have a set of parallel spins, which gives us an energy savings, energy stability. We also have a completely filled half level position D. So this becomes more stable. So our expected is going to be promoting that S electron up into the D. So we're going to have 4s1, 3d5. So this would be our expected electronic configuration. Now for tin 2+. So I'll start off with tin directly. So tin is period 5. So we're going to go backwards and look for a noble gas, and that noble gas is going to be krypton. So we're going to start off with krypton. So I'll do neutral tin first. Neutral tin. So we start off with krypton, Kr. Then we go up into period 5 where tin is. So the first two columns are going to be 5s2. Then we hit the D block, and that'll be 4d, and that is completely filled, so 4d10. And then we're up into 5p. And tin is in the second column of the P, so we have 5p2. So this is the neutral element. So we're looking for what happens when we lose 2 electrons. So when we lose 2 electrons, what electrons we're going to lose? The first rule is that we're going to lose the highest principal energy level electrons first. So that means we're going to lose level 5 electrons before we lose the D electrons. And of course we have 2 5 electrons, so we're going to lose the higher energy of the 5, which is 5p. So we'll end up with krypton. I'll put the 4 first, so 4d10, 5s2. And we could have put the 4 first up here. I was just reading directly off the periodic table. But we lost the 5p electrons for the Sn2+. Now I'll do one more here. Tin has 2 common charges. So the first charge, we lost these 2 electrons. Well, the next charge is going to be losing 2 more electrons, which will give us Sn4+. And that will be krypton 4d10. We've lost that second set of the level 5 electrons, leaving us only with level 4 electrons.